Hi, thank you so much for giving me opportunity to speak here. The maps that I want to show you in this presentation, this is like a joint effort from a bigger group, and you can see the names of everybody who contributed in these maps. So next slide, please. So the reason, I mean, everybody in this room know that why we want to go to SPA Basin, because we have like a lot of unanswered questions we are asking about this region. We want to know more about lunar history, early impact history. We want to test the chronology function, like if validity of it, which the SPA region has so many other basins, not only itself, that can provide various anchor points for the chronology function. And of course, we want to know answers about thermal evolution. And of course, this region has a geological diversity from the oldest basins to the youngest mares. So, of course, this is a very interesting region. The black line in this figure, you are seeing it's the extent of our map. And this dotted line I add in there just to show that, okay, we have still, starting from the basic questions, what is the rim of the SPA basin, to the very complicated questions. And next slide, please. So this is a geological map of the SPA that we have created in this region. And as I was saying, that we have like from oldest terrains to the youngest mares in this region. And normally when we map, we use the stratigraphic system that are set before, like commonly Wilhelm's 1987 stratigraphic system is used. But when we are going to map in a higher resolution, we have to divide the stratigraphic system. For this region, we use the few other stratigraphic markers. One itself is SPA rim material that consists of this light brownish color. You see that's like massif material, um, and it's like exposure of. It could be like not exposure of the rim, but presence of the SPA rim material could be in these massifs. And then the second stratigraphic marker is Engini basins, where we can see some of the rim material as well. Then Apollo Basin, where we can also see the central rim. Then more preserved Schrodinger Basin, and then Orientale Basin, and which is like Orientale Basin is in this region, was added or in addition to SPA, because many of the secondary craters are coming from Orientale Basin, and part of South Pole is added because the rim extension of SPA in this region as well. And next slide, please. So two of the region, no, one before. One slide back, please. Yeah, here. So two of the region that is like not used as a stratigraphic marker, but has a lot of important information related to the formation of processes is region around Poincaré Basin and the region around Bhabha Bose craters. And the region around the Bhabha Bose crater, it's kind of considered as a center of the SPA basin. That could be the region that is representing the floor of the SPA basin. So now next slide, please. So this is the geological map of Poincaré basin region. So the map I showed you before, it was mapped on a scale of 1 to 500,000 scale, and here you can see that this map is 1 to 200,000 scale. So we have another stratigraphic marker added, that's the Poincaré rim material itself. So we have like very little exposure of pre-Nectarian terra. Poincaré is also considered as a pre-Nectarian in its age. And then we have many material from Neckerian and pre-Neckerian that are younger than that. In addition, we have few kinds of plains. We are expecting these plains could be from Neckerian or pre-Neckerian ages. We see the more distribution of light plain material even into the smaller crater at this scale, and then a lot of volcanic episodes. And in ongoing work, we are trying to find out if these are uh, several episodes of volcanic, and we are doing CSFT measurements on these units. Next slide, please. So we did a simple exercise. We took the endurance traverse that is already mentioned before, and we just put the traverse and draw our cross section along the traverse on the geological map to see which kind of samples can be mapped during the traverse. And here we see that many of the samples that can be traversed will be from Neckerian, pre-Neckerian terra. There will be a few samples that could belong to Poincaré Basin. And of course, there will be some samples also from Mare deposits. However, we also see there is a lot of topographic difference between these units, so we expect that the traverse could vary from the places, and then the same exercise can be done to see which samples can be mapped. Next slide, please. So Bhabha Bose region is as I said, is considered as a center of the SPA basin. Here we see a lot of more complexity in geology. We see that there are highland material, like a Neckerian, pre-Neckerian material. There is also Neckerian, pre-Neckerian plains, which are considered. This is something we're expecting or considering if this is the material left over by impact mount of SPA itself, because it's older than any mare, it's older than any other plain material, and it's not very hummocky like other pre-Neckerian terra. Then we have Bhabha Bose craters and stony craters. They are not so much different from age perspective. Their model ages are quite similar, so 3.8 billion year. However, Alder crater is quite younger. Then again, we have several episodes of volcanic in this region, but we are not really sure yet if they are all of the same age or different ages, or because we are still doing CSFT measurements on this region. The only difference we have in this map from previous interpretations is we don't see a mafic mound with this unit near in the south of Bhabha crater, where you see a little bit of overlay. This is expected mafic mound, and in the stratigraphic study, we don't see any evidence of it being a volcanic feature or mound. We see it as a very old leftover of a pre-Neckerian terra. However, in spectral data, you see a mafic signature, and we are still discussing like what could it be? Could it be just a material that is imported from somewhere else, or was there a presence of pre-Neckerian volcanism and it's a buried mound? So these are again a lot of questions we are asking after finishing these geological maps. So next slide, please. So we did the same. Okay. So this is the same exercise we did, like we did in the Poincaré map. We put the endurance traverse on the top of the geological map and see which kind of material we could collect. And we see that we collect a lot of material from Bhabha Bose crater as well. There would be also material from these older plains that I mentioned before. That could be SPA melt material, maybe. And then and luckily there will be also samples that could be collected from mafic mound or at this unit. Anyway, so next slide, please. So yeah, this is like a summary of my talk, but it's like you can see that many of the questions that geological maps are comprehending your scientific queries, but many of the questions you ask after finishing the geological maps, like where you could actually go to answer certain questions. Poincaré exhibit is mainly dominated by impact crater region itself, but there you could see it's enriched with the volcanic processes. Bhabha Bose crater regions may cover the SPA basin floor, and it is diverse in geological processes as well. And this kind of the mapping is called nested geological mapping, which is like you make maps of the same region on a severe scales. If somebody's doing a high resolution mapping than this one, they will also come with a separate, with a more advanced set of questions. So this is the reason nested geological mapping is very important for more scientific queries. So that's all for my talk. Thank you very much.